From our experience, in 8 out of 10 times that people implement RAG, Retrieval-Augmented Generation, there's usually a better solution. So let's try and understand why. If this is the first time you heard about RAG, RAG is an acronym for Retrieval-Augmented Generation, in which we have 3 phases. The first phase is to retrieve similar documents from the past, usually using a vector embedding and a vector store. Then we create a few-shot prompt, meaning that we give a ChatGPT or the LLM down the line some context for previous cases and the resolution. And then we feed the engineered prompt into an LLM, ChatGPT, Claude, Llama 3, whatever, and take its response and provide it back to the user. Now, this is a very naive implementation of RAG. Sometimes we have validations in place or filters, but this is the overall theme. So why am I saying that RAG is usually not the way to go? Let's start with the types of queries. Let's assume I would like to understand how to install my 2710 HP printer. If I were to query a vector store, I would be able to get very similar resolutions for 2720 printer or maybe other printer in the HP series. But I don't care about any of them, right? I care about specifically the 2710 printer. Now, semantic similarity is not the way to go here. I guess that all printers are semantically pretty similar, right? They all print, they're all not really working on the first time we try to install them. So from an embedding point of view, they have the same embedding and they are supposed to have the same embedding. This type of query is called an ID query, where I know exactly what I'm looking for and I only want to retrieve those documents. This is a very strong signal from the user. So usually, before the retrieval stage, we have a classifier, whether it's an ID query or not. Now, ID queries are only one type of queries that need special attention and special care. There are also other types, and vector similarity cannot really handle this kind of queries. The next issue or concern that we have with this RAG architecture is that essentially we have 2 models here, right? We have the vector store and we have the LLM, and we assume that they have anything to do with one another. For example, if I were to generate 4 examples or 10 examples for the LLM, maybe the LLM would decide not to use them. Maybe if I were to generate 1200 examples, then the LLM would actually use the samples down the line, like ranking 1,000 or more. So since these 2 models are not really co-trained or not really optimized for one another, changing the embedding could be catastrophical. And it's really hard from a separation of concerns or good software architecture to make this thing work over time. Minor changes in the vector store could create catastrophic changes in the generator and vice versa. So it's really bad software architecture from point of view of separation of concerns. Now, the last thing I would like to consider, this is not happening yet, but I think that this whole RAG architecture tries to compensate for the fact that LLMs are expensive. So to run a ChatGPT query is a few cents, and you don't want to run it across all of the database for each user query. So that's why we invented this intermediate step of the vector store. But is it? We see new models coming up every week that are cheaper and cheaper. We see people running LLMs on their iPhone, and we see innovative architectures like Mamba and RWKV that actually perform as well as transformers, and they seem to be the way to cut costs. So let's do a thought experiment that in a year from now, running an LLM would be as cheap as just running a calculator. Why not run an LLM using an yes or no question on all of the database and ask it, like, is this clause talking about the user query, yes or no? So in this case, the LLM is obviously consistent with itself, and we don't have the intermediate step of the vector store. And I think that the last failure mode that people run to implement RAG without thinking too much is that, do we actually need the G, the generation step, perhaps it's a retrieval problem. Let's assume I'm trying to find the best resolution for a certain case. For example, I lost my password or any other common cases. Do I really need to generate a different user per client? Maybe I could just retrieve the answer and that's it. So the generation step here is a nice to have step at most. It might be even overcomplicating the system. So I hope I gave you some food for thought, and you should reconsider all of these steps before implementing RAG in your next project.